Hello, everyone, and welcome to another episode of ISTE's Beyond NITK. Today we have with us Vibhav. He was the convener of ISTE for the year 2016-2017. He is currently doing an MSc in Embedded Systems from TU Delft. Hello, Vibhav. How are you?
I'm good, Anit. How are you?
I'm all good, doing great.
That's
So
good to
why
hear.
don't we start off? Thank you so much. So why don't we start off today with a bit about yourself?
Yeah. Hi everyone, and hi Anit. I'm Vibhav Inna Kedege, and I'm currently doing my masters at TU Delft, at Delft in the Netherlands. Prior to this, I was working in a firm called Alstom Transports, which mainly deals with the manufacturing and designing and the verification validation of railway trains and metros. And prior to that, I was a bachelor's in electrical and electronic engineering student at NITK Surathkal. Current a bit about what I'm doing nowadays is about from doing my masters. I'm currently interning at a company, a startup over here called Almende BV, and yeah, I mainly work on control systems and embedded systems out there on robotics.
How has your experience at TU Delft been so far?
Oh, my experience at TU Delft. Oh yeah, it's a good question. It's been quite challenging and exciting at the same time. So it's quite a unique adjective, but yeah, that's the way I'd like to describe my first year. Because in Delft and most of the colleges in the Netherlands, your quarter or your year is divided into 4 quarters. Your year is divided into 4 quarters, and each spans around 2.5 months. So you only have one exam for those particular quarters, and in each quarter you take around 3 to 4 courses, and you need to study those courses quite in depth. So therefore, when you study it in depth, it tends to become quite hectic with the kind of assignments and tests and everything and deliverables basically. But at the same time, what motivates me is that at the end of it you learn a really important skill, something like writing a software on PyTorch, or writing or developing the algorithm for flying a drone, so anything like that. So that is something that's a good takeaway from any course out here.
What exactly motivated you to pursue an MS in Embedded Systems?
I think the fact that embedded systems is so evergreen, and because during my work life also I use embedded systems in a really big way. Because the when I was working a train on trains, and in that a lot of embedded controllers, which control the train, of course. Prior to that, in campus also, I had a lot of experience working in embedded systems, because with things like ISTE projects, that was quite interesting to deal with and work on. And things like during engineer, we would take part in various committees like the Tech Nights and the Electronics Committee. So that really brought into an amalgamation of thought into me that embedded systems is really evergreen, and pursuing it can it's kind of fascinating. Like pursuing it, you can actually control things like robots, nuclear plants, railway trains in my case. So that excitement, I think, brought me here.
Moving onto your campus life, how do you think your journey to NITK has helped you in pursuing an MS?
Oh, I think a lot, in fact, because the MS out here is really application based, with also a lot of theory focus in the beginning. So understanding the mathematics behind why something works as it is something that is really strengthened and in an undergrad course, and especially a rigorous one like we have in NITK. A good example of this is when I started with control theory, understanding how just putting a negative feedback from an output, and that leads to the decreasing of your error margin, is something that really fascinated me at that age. And something, and then triply more per se, it's you have something like power systems that show how you can control the flow of power between different nodes. So that was pretty good. And there were also some application courses which I particularly really liked. So something like there was a course called Embedded System Design, conducted by my department, and the OSVI, conducted by the AppMech department. I think Prithviraj deals with that. And there's one more conducted by the Sense Lab, which is Square, not the Sense Lab, the Solve Lab, which is really good in my opinion. So I think if gold is the main, you definitely should take that.
How was your placement process for Alstom?
The Alstom creation process, yeah, that's quite interesting, and yeah, looking back, it's quite in depth. So the Alstom creation process is it first starts with the your usual technical round where they have, like in my case they had 40 or 50 MCQs of which is related to things like control theory, power, and one more, and software programming and that related, and of course an aptitude section. Then after that, once we clear that, we go into technical interview where they ask you about your projects mainly, and why what experience have you had which is relevant to them, and vice versa. Because Alstom is like a huge company, there are a lot of departments. And the after that, what was kind of different for me was, not for me, for the Alstom procedure, was having a group discussion, which I think is something really important, because as the world is, coming closer, it's really important to put your point in a really coherent way, because you have people of multi diverse backgrounds. So that is something which I found really a good takeaway from the interview process. And of course, the final HR round after that, which deals with um, whether you're willing to travel a lot, because Alstom has deals with trains. So you have, if you go to the manufacturing plant, sometimes you need to do a lot of engineering back in the offices in Bangalore or wherever. So that was only about that.
What do you think are the key qualities required for one who's working in a firm like Alstom?
Oh, so that is a really good question, because at Alstom, I particularly find that European companies, because I did an internship in Bosch before that, and I had a stint of 3 months in Australia, in Sydney. So what governs all this is having a good time sense is something that's really important for such firms. So telling someone that you will come, or very small thing, telling someone that you come on an interview at 3 o'clock means 3 o'clock, not 3:05, 3:10. I mean, 3:05 is okay, but not frowned upon. But after that, it's like completely like, no, it's not. It shows that you don't respect time and all those things, and it's also not good. One more thing is, the ability to gauge your work and tell how much time you take for that is something that probably, something which I learned from one of my managers over there, because it, helps the overall procedure. So when you think on a global point of view, a manager will have to allocate tasks and will have to schedule activities based on that. So if you can clearly tell, okay, I'll take 2 days for writing this piece of software to control probably the train, or probably the lighting of the train or anything, then that's a really good quality to have. And you can in fact start doing it now only if people are interested to do that. You?
What attracted you to Netherlands, particularly TU Delft?
So one thing is my past experience with firms like Alstom and Bosch um, showed me how the Europeans think, and how they, how the technology that they use. And for my course, which is for my field of interest rather, which is embedded systems in controlling devices and cyber physical systems particularly, I found that Europe was a slightly better thing for me, and I liked it. And also, I did not have any interest of permanently moving to the USA, so that factor was out. And yeah, so I think based on that, I shortlisted Europe. Now within Europe is big, of course. So you have a lot of countries. So I so the first thing was narrowing down which country. So that is based on specialization. One is I was clear on embedded, and I went through UK as one of the options, but it was quite an uncertain environment last year because of the Brexit and everything. So I wasn't very sure of that. Germany was one very strong option, but my German wasn't that high, so I know a little German. But for studying in German, medium, you need at least a B2 or a C1 level. And the ones that I mean, it's not that most of them don't teach in English, but the ones that taught in English were not quite interesting for me. like they're mainly based on computer-aided CAD, not CAD, computer-aided mechanical design and vehicle engineering. That's a popular field, but purely embedded there was not much from what I saw. Then the other options was which I liked were Sweden and Netherlands. Now both these countries are very unique because the level of English that people speak is very high. So it's almost like it's their other language itself. So the choices between these two. But one thing, like you should learn the language when you come here. It's really beneficial for day-to-day activities and all. Having said that, um, so the choice between Sweden and Netherlands. Now Netherlands, I felt within the colleges I found TU Delft and KTH to be two options. And TU Delft had is the ranking of TU Delft is quite high, and it's going up year by year because this year it came second in the world in the systems and control department where I'm doing my minor specialization, and it's also currently 15th in the world, so that's quite good. That happened now, and it's centrally located more than Scandinavia, I thought, because it's very close to Germany, UK, France, and what I've heard, which I'm still yet to realize, is that TU Delft, because of its ranking, it's also the name is quite well known. So, and the course content was very flexible and it was very good. So, you being an embedded system student, because so evergreen, I could choose any course, and it had application oriented research, so which I thought was very important for a course in embedded. And plus, in the Netherlands, I'm not sure about in Sweden. I think Sweden also, if you decide to do a PhD, it's actually considered like a regular job. So you have a regular salary, like you consider like a regular PhD employee or a PhD candidate, and that is also perfect for. And it's most of the projects are industry oriented, so hence Netherlands was the perfect choice because of all this.
How is the application process for an MS in your college?
So in terms of the application procedure, you have to give your TOEFL scores, which usually should be greater than 90 in my year. There should be you for embedded systems, computer engineering, computer science, and aerospace. I was required to give my GRE scores, and usually 320 above is a good score, I would say, for TU Delft. At least back in 2000, when I joined 2018 application time. You need an SOP for 1,500 words, and you need two letters of recommendation and a GPA of greater than 8 CGPA. One important thing to note is you should apply like quite early, because so when in my case, applications opened on 15th of October. I applied by 20th of October, and that's what they mentioned on the website also. So, and you get your results by December itself. So that's like really quick, and it's like really streamlined after that. So I would say, yeah, that is one thing. There's also an important link I can share with you on this video. Probably that will be really good for writing an SOP, because it clearly mentioned what you need, what you should write, and all these things.
Which all colleges would you suggest students who want to pursue an MS in embedded systems look into?
Yes, yeah. So from my research and back then and currently, what I'm seeing as a trend in Europe is that TU Delft is of course good. That's where I am. Yeah. KTH is awesome. TU Delft, TU Eindhoven. That's so Eindhoven is like the future Silicon Valley of the Benelux area, the Belgium, Netherlands, and Luxembourg area. And RWTH Aachen in Germany. That's really good. There's also University of Stuttgart, and Stuttgart, it's like the home to awesome companies like Bosch, I think Bosch and Daimler, and one more, I think Porsche. So that's got really good opportunities, and the industry collaboration is really good. ETH Zurich, if you want to go a little bit deeper into the sciences behind electrical and computer engineering, but ETH Zurich is like known world over, so it's like an amazing field, and they have some really groundbreaking research. There's also one more thing which I found really interesting was Erasmus Mundus for embedded systems. So in that, you can spend 1 year in one country, another in another country, and the countries and the universities where you can take part are one is University of TU Kaiserslautern in Germany, the NTNU, that's Norway, and University of Southampton in London. So you should definitely check that out. That's a really good, that's good, really good exposure also. In terms of USA, I saw a few colleges like Georgia Tech is good. Georgia Tech is really good for especially the systems and control specialization is kind of related to what I'm doing. CMU, I mean, I don't have to say words on that. They do really good research. And if you have the financial means, I think University of Pennsylvania also has a 1-year embedded program. It's good. In Canada, McGill is quite nice. And of course, in Singapore, NUS and NTU are, that's also really good, but highly competitive, but good.
Took up an MS after your job, after a work experience. Would you suggest one follow the same, as in they take up an MS after a job experience, or they have to go for it soon after college?
I think, yeah. So I think in my case, I was quite confused between an MBA and an MS, or not, neither those two also. When I finished college, I was quite confused between an MS or an MBA or something completely different. So in that case, I chose going for a job at first, and while doing that, in my case, it was quite good. If you're completely sure of doing on your choice, like embedded systems is my case, or maybe something like power systems or digital electronics or various in your case, you can start immediately, because there's something that's very important that you have, that 2 years of work ex kind of lessons is the ability to study. Actually, that's something like really underrated, but you need that in an MS degree. So so if you're completely set on your path and your research, then I think going directly after college is good. But after that, if you're still unsure, then you should go for work experience first, in my opinion, because going for an MS requires a lot of commitment, financially, physically and mentally. So I think, yeah, it would be better to do that first.
What are some upcoming things in your field that your students should look out for?
Oh yeah, that's a really good question. One is the in a more theoretical sense, there's the concept of distributed algorithms and distributed controllers is something really good. Like, instead of relying on only one controller, many critical applications, you need more of them. Or why not have the agents or the commodities that you're controlling itself think about what to do next? So that's a really hot topic that's going on. The other thing is deep reinforcement learning. There are some scenarios when you start working on, or when you start developing applications, that you don't really think about. So in that case, writing a deep reinforcement learning algorithm to learn those conditions can be fruitful, but it's only currently in research, because you don't really know how stable the controller will be. The other thing is quantum computing, which is, I think, going to be a really big thing, because you can single-handedly map a lot of data. Instead of mapping in ones and zeros, you can map it in one and an unknown state and zero. And the other thing is tactile internet. So we've mastered sending voice, video, sound, etc. through the internet. But how do you send the sense of touch through the internet? So I think with the current corona problem, I think that should also be quite an interesting field to look into. In terms of applications, what I feel is currently at most at the need, as we see now, is using embedded systems and all these concepts that we learned into renewable energy sources, because there's no hard truth that currently the planet is not the same as it was 10 years back. So things like sustainable development, sustainable energy is something that I think we should really look into. So that's one advice for the people, because there's nothing more important than doing that at the moment, in my opinion.
Given that this is a time of uncertainty, what revolutionary impact do you think COVID-19 would have in your field?
I think firstly, the biggest revolution would be in the development of test kits for corona. That's the first thing. It's already happening, but I think there's still a lot of research into doing that. So that includes a lot of embedded, like sensors measuring the number of pulses, the blood flow, and then the DNA or whatever that causes corona. I think that will be a good thing. That'll be a big revolutionary thing at the moment. And having more devices connected to the internet was always the aim. Like, people suggested that 2020, that's now, or 2030, is going to be the time when majority of the devices are going to be connected to the internet, like all the curtains and home automation, robots and everything. So I think that is one thing that's going to be accelerated even more by COVID, with less amount of social, talking to each other in a physical space. So that is quite important. And what this leads to is possibly more opportunities in companies like Amazon, which has a lot of drone delivery, and GE Healthcare is one which I was seeing that has a lot of COVID development cases, COVID this thing instrumentation development, and the other thing is a lot of startups are also coming. Bangalore is full of them, and even Netherlands at the moment. So yeah, these are some areas which you definitely should expect something big to happen.
Finally, before we wrap off this interview, any general advice for those who are looking into an MS in embedded systems?
Yes, yeah, that's quite a good thing. So maybe I can look at it from a point of view that I thought when coming here and realizing it now, of course. So that is one is if you take a data structures and algorithms course and a C++ course, this is more deeper into embedded systems. It helps a lot. It helps quite a lot because you get the general intuition on how to think about uh, writing software in a quick and easy manner. And if you're ever developing embedded products, this is mainly in terms of development of products, which if you pursue masters, you will definitely do, or if you like the course, is that you should generally think about long-term feasibility of the product. So, I mean, a lot of us have the tendency, including myself, to keep a wire dangling out of the circuit and then focusing more on the software. But that is not the case. You need to focus on how to get a good PCB printed for a particular hardware. And yeah, that is one thing. The other thing is a very important thing is developing an intuition of how much memory capacity your devices have. So for example, if I say, okay, this has 32 MB of memory. So you should imagine what you're writing so that you know that 32 MB is like a real big amount of memory or a small amount of memory. So you should keep that intuition with respect to your software. So I think that should be really good. In terms of more of application level, application meaning the college application level, I think if you're trying for masters in embedded systems, you can start thinking about it in March itself, I would say, because or maybe May if you're really having some things some difficulty in thinking of that. So you should possibly think about, because it's a long procedure and it's not difficult. I would say it's more about being tenacious in doing that, like preparing for GRE or writing or getting letters of recommendations. So it does take some time. So I think you should be prepared for anything during that point of time.
Thank you so much, Vibhav. And this brings us to the close of our interview. Have a good day.
Thank you.
If you found this helpful, do hit the like button below. And don't forget to share and subscribe to find out about more opportunities beyond NITK.